Okay, we're going to go over the concept of slope, okay? And we've talked briefly about y equals mx plus b. This is the equation of a linear or a linear equation or a linear function, and it represents a line. And a line will have what's called a slope to it. It's the one way of describing the, I guess, angle of the line. Okay, they don't do degrees or you learn radians, but we talk about slope, and that's called the rise over the run. Now the slope in our equation here is our m. Okay, this stands for slope. And I'm going to tell you all the many things that slope is equal to. And really, for our purposes, we just have to know that m is equal to slope in this equation. Okay, but slope is equal to so many very different things that come in very handy later that we're going to make a list. Slope is equal to, and one way they describe it is the rise over the run. Okay, and I'm going to make a brief sketch of a coordinate plane here. And what they mean by rise over the run is how much you go up or down. That would be the rise. You either have a positive rise to go up or you have a negative rise to go downwards. And the run is left to right on this, right? And a positive run is to the right and a negative run is to the left. Which makes sense, right? Because on the y-axis, this is positive, this is negative in terms of rising. And on the x-axis, to the right is positive and to the left is negative. Okay, so that's what they're talking about with rise and over run. That's how we move around a grid. Okay, so we'll talk about how slope is equal to that idea. I'll move this kind of out of the way. With that being said, rise, as we can tell, refers to the y-axis. So we're really talking about what's called the change, and they use a triangle in math sometimes to represent change. Yeah. The change in y over the change in x. Okay. And there's a way we can calculate the change in y and the change in x. Say we have two coordinates. So I have this point and this point, and I want to create a line. And as long as we have 2 points, it's not the greatest line, but I can create a line as long as I have 2 points. But I need to figure out the slope of this line. Well, that refers to the rise. So that's the up and down point over the run. Okay. Well, we know each of these coordinates, or each of these points will have coordinates, x and y and x and y, and we have to define the two of them. So let's call this coordinate 1, so this will be x1, y1, and this will be coordinate 2, x2, y2. Okay. Algebraically, we can figure out the slope by taking y2 minus y1. Okay, so that's the change in the y-axis. Okay, remember how we talked about how rise is change in y? Well, we take the two values, y2 minus y1, over x2 minus x1. Okay, so I did a lot of proof here, which is really tough to work with. We're actually going to take 2 points and apply this knowledge. Okay, so this is kind of theory what we've done here. So it seems a little confusing. But let's say they gave us 2 points. Oh, I don't know, 6 and 2, and maybe -3 and -8, something like that. Okay, and they want us to find what the slope is. What is the slope to all of this? Okay, well, we can work with it. We can figure this out. In fact, what we're going to do is we're going to get I think I can bring up Desmos here. We're going to go into our graphing calculator program here. I've plotted the 2 points. 6, 2, which is this point here. And we'll draw it. This coordinate here represents 6, 2. Okay. And then our other coordinate was -3, -8. And that's this coordinate here. It's at -3 and -8. So I have 2 points, okay, and I can connect them. And I'm going to do my best. Can I draw a line with this? Don't really know how, so I'm going to do my best freehand. Yeah, that's not bad. And there's our linear line. But we need to figure out the rise over the run. So we have to figure out rise divided by the run. Okay, so what we're going to do is we're going to algebraically figure out what the slope or the rise over the run is in this question, okay? So I'm going to take this off here and go back to our coordinates. So we take these 2 points. Algebraically, let's figure this out. Remember, our formula stated that y2 subtract y1 divided by x2 subtract x1 is equal to the slope, which is, if we're making our y equals mx plus b, that's the m value. So this is the m value. This is how we find it. Well, I'm going to have to number these, right? So let's call this guy coordinate 1. And it doesn't matter which one we call which, because I can play with these, okay? This will be x1, y1. which means if this is coordinate 2, this will be x2, y2. Okay, so we're going to take these values and plug it into this formula. y2 is negative 8. So we start with negative 8, okay? Subtract. Try to color code this way.
Algebraically?
Yeah. Positive 2, so we subtract positive 2. All divided by.
Wait, I don't know which one's the rise and which one's the rise.
We're gonna show you that in a sec. Okay? And our x2, which was negative 3. Oops, I need the pen here. This was negative 3 to expand this page. Subtract. Let's scroll up. What was our x1? Our x1 was 6. Okay? Does it make sense how I've put the numbers out here? We'll work the rest in black. Okay? M. I'm going to say M. That's what slope is. So I took the coordinates and I plugged it into this formula. Okay? So let's work this idea out. What is negative 8 subtract 2? Do you know off the top of your head what that would be? Or do you want me to do it?
Oh, 10?
Negative 10. Good. So we have negative 10 divided by, and what's negative 3 minus 6?
9.
Negative
9.
9. That's right. So our slope is negative 10 over negative 9. Now, or, what's a negative divided by a negative?
Positive.
Positive. So I want to go over this concept. Or it could technically be 10 over 9. So I have two slopes, which could be confusing. How do I have two slopes? Let's actually go about plotting this. Okay.
We learned this today.
Did you learn this today?
Yeah.
Good. So let's talk about this actual concept here. We'll go back into our graphing calculator program. This is considered a positive slope. Okay. And the reason being is when we go look at this. Okay. Here's the slope of our line. So let's go back into this. We have our line. And according to this, we go up 10, which is negative 3 to 6. Is that what it was? Yeah, you can't really reduce that. So we went a rise. Okay. We rose positive 10. And we ran over. Our run was positive 9. Okay. But let's say we want to extend this line. Okay. I'll have to kind of zoom out from here. I don't know if I can. So now, that kind of deletes all that. That's okay. We figured out that part. If we wanted to extend it, well, the other way we could do this is we could go negative 10 downwards and to the left, negative 9. Okay, so our next coordinate on our line, as you see, lines up perfectly. Okay, so whether we went up 10 and over 9 this way, so we went positive 10 a rise and positive 9, or the reverse, it's still the exact same slope. We're on the exact same line. So, we'll finally get rid of this. If we were to put this in practice to our equation of a line, got too many applications over here. Oops. Our equation of a line, it would say y is equal to, and the slope we know is, and we usually write it as a full positive or full negative. We usually don't tend to write this version here. We would say 10 over 9x. Okay.
We usually write it as what? Y?
Let's say, let me finish this first and then we'll get into that concept. And we haven't actually figured out what the y-intercept is because that's not what this lesson's about. We're just working the slope. But let's say we had something a little bit different. Okay, I'm just pulling this number out of anywhere. Let's say my slope happened to be, negative 3 over 5. Okay, well that's negative 3 over, think of it like positive 5. I can rewrite that slope as positive 3 over negative 5. And if you think of it as a whole, what is a negative divided by a positive?
A negative.
A negative. So really it's negative 3 over 5, the whole number. So it's a negative slope. Okay, and they can be written two different ways either. Okay, you could technically have written this as negative 10 over negative 9, but we know that simplifies into just a positive value. This, as a whole number here, this guy here is technically positive 10 over 9, just like this guy's negative 3 over 5.